Hello, a very good morning. It's a good day for maths. So, for this question number 5, it's revolving around the topics of graphs and coordinate geometry. Now, for part A, basically you see a straight line here, right? And we have to find a possible equation for the line. Notice that they use the word possible, meaning there are many possible answers to this. So, if you recall from coordinate geometry and straight lines, an equation of the line looks as such. Y equals to mx plus c, or xy are coordinates on the point, m referring to the gradient, the slope of the line, and c referring to the y-intercept, where the line passes through the y-axis, that value. Okay, so since there are many possible answers, basically you observe this straight line is positively sloped. In other words, it's rising from left to right, upward sloping. So any positive value would do. So you could choose, for example, I can choose m to be 2. Okay, you could choose 3, larger and larger, it doesn't matter, as long as you choose a positive value for m. Now, for c, however, the y-intercept, notice that it passes through here. And this is the positive y region, and this is the negative y region. So therefore, your value of c has to be a negative value. It cannot be positive in value. So you can choose, just feel like a negative 3 today. So now if I put these two values there, I am now able to write down a possible equation of this line. Y equals to positive 2x minus 3. So there are many possible values for this part A. Right, so moving on. Part B. Now we have a different equation, so we have to reset our mind a bit. And if you observe the equation, what type of an equation is this? Very good. It's a quadratic equation. And quadratic, we talk about equations where the power of x is at maximum 2, or x squared, etc., etc. So most of them look like a form of ax squared plus bx plus c. And if I really expanded this part here with the brackets, I would get something that looks like this, ax squared plus bx plus c. Now the question is, does it have a maximum point or a minimum point? So for quadratic graphs, recall they either have a shape of a bowl like this with a minimum point, or a mountain like this with a maximum point. So now if you just quickly observe that in this equation, the coefficient of x will be a positive 1 when it's expanded out. So when it's positive, it is going to be a U-shaped graph with a minimum point. Next, to find the exact coordinates, recall coordinates is talking about the x and the corresponding y that lies on that equation. So if I look at this equation here, for understanding reasons, if I wanted the minimum or smallest y value, which is here, everyone, smallest. I want this to be as small as possible. Then I have to ask myself, how do I make this expression as small as possible too? And in particular, how do I choose the x here to make this expression as small as possible for y? Clearly 12 is out of our hands, so I can't do anything to it. I just have to choose an x to make this as small as possible. So what is the smallest possible value here when I square any number. Can I ever get a negative number if I squared a real number? The answer is no. I can always get a positive number. So what is the smallest value I can get with a number that is squared? Very good. It's 0. And that only happens when x is chosen to be -4, so that when I get -4 plus 4, I will get 0 squared. So I will intentionally choose x to be -4 to make this whole expression 0, and therefore, when x is -4, y will be 0 plus 12, which is the corresponding 12. And that is the coordinates of the minimum point.